So far we have seen the basic logic development and the decision making in Python programming. You can find a manual given in the description for some practice problems related to the things we have covered so far. In this lesson we will study about one very important concept known as user-defined functions or simply function. We have used functions of math module. For example, sqrt is a function to find the square root of a number. We can create our own functions and that is what we will study in this lesson. Before I write a function, let me show you this program first and then we will redo this using the function. This program is taking 3 triangles from the user and then displaying the area of all 3 of those. Here I am taking 3 triangle sides from the user and this is the calculation of the area of the first triangle and these are the calculations for the other 2 triangles area. And then I am printing those areas. Or maybe there can be a task to display the largest of the 3 areas, but we need to find the areas 3 times and that's where a function can be helpful. We are doing the same calculations 3 times on these lines, so instead of that, we can create a function for that and then we can use that function 3 times instead of doing the same calculations 3 times. So I hope you got the key idea here. So now let's see that in coding. Using a function is known as calling a function. We say that a function is called. To define a function, we use keyword def followed by the name of the function. For example, area try. The naming rules of the functions are same as the naming rule of the variables. Then we have to put the parentheses and then inside the parentheses, we can specify input arguments. Input arguments means input parameters. To find the area of a triangle from its sides, I need to know the 3 sides of the triangle. So the 3 sides of a triangle are the input of the function or the input argument of the function. The function will calculate the area of the triangle and that area is the output argument or the output parameter of the function. So I'm specifying 3 sides as A, B and C. You might be thinking that these A, B and C are not defined yet. But what it means is that we are defining a function with name area try and if 3 inputs suppose A, B and C are given as the input argument to this function must find the area of the triangle. So you can say if I have A, B and C as the sides of the triangle, I must do the calculation for the area of that triangle. So after the colon, when I press enter, you can see an indentation over there, just like the block of if statement or the else statement. So this is the block of the function where we'll be doing the calculations. So this capital A on line number 4 is the area of the triangle having sides A, B and C. To specify the output argument, we use the return statement. For example, return A means this function will be returning or giving the value of A. There can be many variables inside the function. For example, the variable S on line number 3, but we know that the area is calculated in the variable A, so we specify that by using the return statement. So this completes our function. So now let's come out of the function and take in the 3 sides of a triangle from the user. And now instead of doing the area calculations, I can use area try function and will specify the input arguments as A, B and C which are provided by the user on line number 7. You can see on line number 8 I have used a different variable name for the output argument of the function as A1 instead of A because it is not required to use the same output argument name as being used inside the function. The same is true for the input arguments, but I'm using the same variable name just to avoid the confusion to start with, and we'll discuss this point a bit later. So when line number 8 will be executed by the interpreter will call the function, meaning that it will execute these 3 lines and the value returned will be stored in variable A1 of line number 8. Now I can do the same for second triangle. I'm saving the area in variable A2 this time. Now let's do for the third triangle. and the final result is displayed on this line. Let's see the two codes side by side. In first case, we are doing these calculations multiple times, while on the second approach, we have done the calculation once, made those calculations as a function, and then we are calling that function 3 times. You might be thinking that it's not a very big advantage, since in first case we have 2 lines of code for the area calculations, and in second case, instead of those 2 lines, we are calling the function. But imagine we have some calculations which are completed on 10 lines or 20 lines, and we need to do those calculations 4 or 5 times. So instead of writing those statements 4 to 5 times, we can create a function and then we can call that function 4 or 5 times or even more than that. Now let's see how this code gets executed. The first very important thing that you should know is that a function does not get executed by itself unless it is being called. So after line number 1, the interpreter will move to line number 7. The first line is just an import statement, so maybe you can say the first line executed by the code will be line number 7. Let's first run the code and see if it is giving the output or not. To see the step-by-step execution of the code, I will place the breakpoint on line number 7 and let's run the code in debugging mode. The interpreter has stopped on line number 7, but do not assume that it has executed line number 3 or 4. Let's press step into. It's asking for the 3 sides of the triangle. And now it has stopped at line number 8. Here we are calling the function area try. You can see special variables and function variables on the variable window. Just ignore those and you can see the program variables over there. On line number 8 we are calling the function area try and we have given the input parameters as a, b and c, which has the values 2, 3 and 4. So execution of this statement means the interpreter must execute the function. So if I press step into, interpreter has jumped to the line number 3, which is the first statement of the block of the function. It will execute this statement and will move to the next statement. Now it will execute line number 4, capital A will get a value and it will move to line number 5. Now this is the returning statement of the function, which means that it will return to the line where it was called, which is line number 8, and it will return that value to the variable specified over there, which is A1 on line number 8. So let's see that. So it is on line number 8 now, and if I press step into one more time, and the value will be assigned to variable A1. You can see the value of A1 on the variable window as well. Now it's executing line number 10 and asking for the sides of the second triangle. Now interpreter is on line number 11, where again we are calling the function area try. So when I will press step into one more time, it will jump to the function body once again, will execute those calculations over there and will return back to line number 11 after the return statement of the function, and the value returned by the function will be assigned to variable A2. And now in next step, it will execute line number 13. After entering the values, it is on line number 14, where we are calling the function one more time, and now again it will jump to the body of the function, will do the calculation one more time and will return the value to variable A3. And finally is this last print statement. So I hope you have understood the execution of the functions. Whenever they are called, the flow of the program is transferred to the function body or the function block, and when there is a return statement over there or the end of the function without any return statement, which we will see later on, the interpreter jumps back to the point where the function was called. Another very important advantage of the function is that if we have done some mistake in the calculation, we need to correct that in the function only. And wherever the function is called, for example 20 times a function is being called in a program, so that change is reflected on all those 20 points. But if we are not writing the function and we are doing the 20 calculations on 20 points, then we would need to correct that on all those 20 locations. Now we will talk about the variable names inside the function. which can be very confusing for the beginners. On line number 7, I have used variables a, b and c and then used those on area try function on line number 8. We have the same variable names a, b and c as the input argument of the function area try. So is that mean that we have to use the same variable names as specified on the function definition while using or calling that function? The answer is no. I use the same variable names for simplicity, but that is not a requirement. The requirement is that function takes 3 input arguments, so while using or calling that function, I have to specify 3 input arguments, but they can have different names. So instead of a, b and c, I can use a1, b1 and c1 or a2, b2 or c2 like we were doing in the previous example. What happens is that when we call the function, for example as on line number 11, and we are passing in the input arguments as a1, b1 and c1, but when interpreter jumps into the function body, it will assign those values to a, b and c of the function body. So a1 will be assigned to a, b1 will be assigned to b and c1 will be assigned to c. These input arguments are also known as positional argument. Their position is important. So in this case, whatever is the first input argument we are passing while calling the function, that will be assigned to the first input argument of the function, which is a, and likewise the second and third input argument. Let's see this happening on step-by-step mode. I'll place the breakpoint on line number 11, which is the line where we are calling the function first time, and I have called that function on variables a1, b1 and c1, while the function variables on line number 2 are a, b and c. So line number 7, 8 and 9 will get executed first. Let's provide some sides values. And now interpreter has stopped on line number 11. Keep an eye on the variable window. You can see the 9 variables and the values we entered a while ago. Now if I press step into, we know the interpreter will jump to the function body and see carefully the variable window. Now instead of a1, b1, c1 or a2, b2, c2 or a3, b3, c3, what we see is a, b and c. And the values are 3, 4 and 5, which were the values of a1, b1 and c1. So you can see what happened is the value of a1 is assigned to variable a, value of b1 is assigned to variable b, and so as the c1 to variable c. And also note that we don't see the other variables now. So here I will tell you a little about the local variables. A function's variables are local variables. What it means is that they are defined locally. So these variables a, b and c have their existence only inside the function. Outside the function we didn't see these values a, b and c, which means that outside the function these variables were not defined, and they exist only inside the function, as you can see over here. The interpreter is inside the function body and the variable on the variable window are just a, b and c. Now when I press step into, the variable s is calculated and we can see this variable in the variable window as well. Then variable a is calculated and now interpreter has stopped on return statement. Now if I press step into, it will jump back to the location where the function was called, which is line number 11. See the variable window now. Now we don't have a, b, c and s or capital A. They were the variables which were defined inside the function. Over here they don't exist. And here we have previous variables a1, b1, c1 and a2, b2, c2 and so on. You can also see a return variable over there, which basically handles how the value is returned to the point where the function was called. You can ignore that for the time being and just focus on the variables outside the function and inside the function. Now interpreter is on line number 12. Over there we are calling the function again and we are providing the input arguments as a2, b2 and c2. Their values are 4, 4 and 5. So now when I will press step into, it will jump to the function body and see carefully the variable window. Firstly, notice that we don't have s variable over there because that previous call to this function has nothing to do with this new call. So the variable s which was there in the previous call to this function is not present here in the second call. And also see the values of a, b and c. These are 4, 4 and 5, which are the values of a2, b2 and c2. Pressing the step into will calculate the s variable and then the a variable. The return statement will make it jump to the point where it was called, which is line number 12. And again now we have different variables in the variable window. So I will do the next step into quickly and you can observe the same thing. So I hope you got the idea what is meant by the positional arguments. A function input argument by default are positional input arguments, meaning that when we are calling the function, the position of input argument is important. And also you got the idea of local variables. Just to elaborate that a little bit more, consider that you have two different programs, so variables of one program are not linked to the variables of the other program, which means that they are local variable. Even if the two programs have same variable names, for example there is variable x in both programs, but the x variable in one program has no link with the x variable of some other program. Similarly, the variables inside the function and outside the functions are local variables, and even if we use the same variables name as we were doing previously, like we were calling the function on variables a, b and c, and the function input arguments were also a, b and c, so those a, b and c are different, meaning that the variables a, b and c outside the function are defined on some other memory locations, and the variables a, b and c inside the function are defined on some other memory locations. Memory location is a physical location where a variable is defined. So it means that physically those variables are different even though they have the same name. Very much like if we have roll number 1 in one class and roll number 1 in another class. Those are two different persons but have the same roll number. Although it is not very difficult concept, but I have seen students struggling on understanding this concept. So I will explain this with the square root function, which we have used a couple of times. This square root function is defined in the module math, and what we need to know to use this function. We need to know its name, which is sqrt, and we need to know that it has one input argument. Now what should be the name of that input argument? Should it be x or y or z? So it doesn't matter. I can pass the variable x as the input argument of sqrt. I can pass the variable a if I want, or even I can pass the direct value. So in the definition of this sqrt inside the math module, there would be some variable name to specify as the input argument, but we don't need to know the variable name over there. We just need to know that we have to pass one input argument, and then we can pass that input argument by any variable name or even directly the value. So likewise, if we are defining the function by ourselves, like this area try, and we have specified three input arguments a, b and c, then while using the function, we need to know the name of the function, which is area try, and we have to pass three input arguments. They can have any name like a1 b1 or c1, or even c1 b1 a1, or they can have same name like abc, or they can have direct values like 10 4 7. In this function, we just have two calculations to do inside the function, but we can have as lengthy calculation as we want. So let's create a function which will have three numbers as input argument, and it will return the biggest of the three. So I'm naming the function as biggest of 3. The input arguments names are x, y and z, and here we will use if statements to find the biggest of 3 x, y and z. We are returning the variable b, which has the biggest value. While calling this function, I can use the other variable names instead of x, y and z, so I'm taking input in variables a, b and c. We can have any variable name for the output argument. We can also directly call the function inside the print statement. I mentioned earlier that the functions are executed when they are called. So although the function is starting from line number 1, so when we run this code, interpreter will read the line number 1, it will see that it is a function, so it will not execute it. And effectively the first statement which the interpreter will execute is line number 10. So we can say that our program is basically starting from line number 10. In many other programming languages, there is a mandatory function known as main function, and that is the function which interpreter or compiler will execute. So over there, if it is just one or two lines of code, those have to be written inside the function main. So in case of Python, we don't have that main function, but somehow we can say that our main program is starting from line number 10. So usually I mention that by a comment as so. So it gives a better visual impression that the main logic of the program is starting from this line. Now let's discuss the next point. We have seen the functions with one returning value, meaning that it has one output argument, but we can have the functions with multiple return values. Remember, for that, we will return multiple values in one return statement. Let's see such case. One such example can be a quadratic equation. We know that there are two roots of a quadratic equation. So if I want to create a function for that, that function should have three input arguments, which will be the coefficients of quadratic equation a, b and c, and it should have two output arguments as the roots of the equation. So let's create that here. I hope I am doing the correct calculations. The two roots have been calculated on variables r1 and r2, and I can return both of those in one return statement. Now let's see the use of this function. Because this function has two output arguments, so I must specify two variables while calling this function. And instead of r1 and r2, I can use some other variable names. For example, let's use x1 and x2. And if I have to find the solution of another equation, I can simply call the function one more time. And now I am using the output variables as y1 and y2. Now maybe some of you is thinking that to find the solution of two quadratic equations, we can run the program two times, and even if we don't have the function, still we can very easily find the quadratic equation solution. But think of some other case. For example, you are doing some physics calculations, and for those calculations you need to solve, let's say, 5 or 6 quadratic equations. So in one program you need to solve 5 or 6 quadratic equations, and you have other calculations as well in that program. The basic goal is not the solution of quadratic equation, but some other physics calculations. So you can see that creating this function will be very helpful. You will create this once and then you can use it 5 or more times. Now I will come back to this program where we wrote a function biggest of 3, which is returning the biggest of 3 input arguments. We saw that we can return one or multiple values in one return statement, but the next question is that is there only one return statement in one function? The answer is that a function can have multiple return statements. What can be use of that? We will see that use over here. In this example, you know that the three if statements on line number 2, line number 4 and line number 6 are independent. So even if the condition of line number 2 is true, still the interpreter will check the other two if statements. So even if the first value is the biggest value and that has been decided on line number 2 and 3, still the interpreter will check the other if conditions. We can see that in step-by-step mode. I have entered 20, 10 and 5. The print statement of line number 12 is calling the function, so the interpreter will move into the function body. This if condition is true, the first value 20 is assigned to variable b. The decision has been made over here, the biggest value is 20, but you see the interpreter will check the other if conditions. Now let's update the code in a way that when the first if condition is true and the first value is the biggest value, we can use the return statement over there, returning the value of x. The return statement means that the function has done its calculations and interpreter will jump to the location where it was called. So with this approach, if the first value is the largest value, the interpreter will jump from line number 3 to the point where it was called, and it will not execute the remaining part of the function. But of course we need the remaining part, because if the first value is not the biggest value, then we need to check line number 4 condition and line number 6 condition. And similarly for the second condition, if the first condition is false and the second condition is true, which means the value of y is the largest value, then we can directly return that value over there. And similarly for the third case. Now let's rerun the code with the first value as the biggest of the three and see the step-by-step execution of the code. Interpreter is on line number 2, it will check the first condition which is true. So now it is on line number 3. And you can see it has jumped to line number 12. So as compared to previous case, 2 extra lines are not executed. So we can say that in this version of the code, if the first value is the largest value, we are saving some time. You might be thinking that it's a very little time we are saving, like 2 instructions might be taking a couple of microseconds only, but still it is important. As a good programmer, you have to look for the efficient solution of your problem. Now the last point I will discuss in this lesson, that we can have a function without any input argument, and we can also have a function without any return statement. I am defining a function with the name intro. If it doesn't have any input argument, still I have to place those parentheses over there. I just want to display some information on the output screen when this function will be called. For example, my name and my great university. And I am not returning anything as well. When there is no return statement in the function, it means that when it will be called, the function body will get executed till the end of the function body. To use this function, I will simply write its name and I will not assign it to some variable because it is not returning anything. And again I have to put the parentheses over there. So if I run that, you can see the output of those print statements. What if I assign it to some variable like x equal to intro? Still we have the same output, but what is inside the variable x? Let's see that by printing the value of x. And you can see it is printed as none. So none is another data type in Python. When a function is not returning anything and we are assigning that to some variable, so that means none is returned by the function and that will be stored in that variable. Let's see what happens if I call this function inside the print statement. You can see the output of 2 print statements of the function, and again you can see that none. Why is that there now? Because the print statement of line number 6 is supposed to print the returning value of the function, and the returning value is none. So please go through lab manual 7, and the last task of this lab manual is the electricity bill calculator, which we did earlier, but this time you have to create a function for that. And let me ask you one thing, if you have to create this function bill calculator, how many should be its input argument and how many should be its output arguments? I hope you can easily identify that it will have one input argument and that will be the units consumed, and it will have one output argument which will be the amount of the bill. But if you have to calculate 2 bill amounts, one within the due date and one after the due date, then the function will have 2 output arguments. I forgot to mention this kind of a string which we write inside the function. I will explain that in a while, but first see carefully how this function is used over here. In the main program, you will just take the units from the user, you will call the function, it will calculate the amount of the bill and it will print that value. I haven't shown here that the amount after the due date is also calculated, but you should add that part as well. Now coming to that string inside the function, that string is known as docstring, which means document string. What it does is, it specifies what the function is doing. So instead of a comment, we can directly write it as a string, but it should be the first line of the function. For example, for this function, I can write that it returns the roots of the quadratic equation. So that's all from this lesson. Thanks for watching.